Hello, today we're going to look at a paper called Design of Low Power 4-bit ALU using 32 nanometer FinFET technology. In this paper, they don't actually deal with how to build the ALU, they deal with more about if it is possible to build the ALU using FinFET technology, and if so, how much leakage power it has. So usually we build ALUs and other circuit elements using MOSFETs, but MOSFETs, they present some disadvantages. Um, according to Moore's law, the number of transistors in a certain IC tends to double every 2 years approximately. But for this to happen, the area of the transistors must decrease. But as the length of the transistors keep decreasing, then the transistor MOSFET becomes more vulnerable to something called the short channel effects. These short channel effects, they're very detrimental to the operation of transistors. So that is why we are coming up with new techniques and new technologies to combat this short channel effects, and one of those new technologies is FinFET. Okay, so first we're going to see the actual structure of the FinFET. Okay, here we can see the actual structure of the FinFET. FinFETs are called quasi-planar field effect transistors. MOSFETs, as opposed to MOSFETs, which are actual planar field effect transistors. Looking at this diagram, we can see that the source and the drain, they are above the body, they're protruding out of the body as opposed to being inside the body as in the case of MOSFETs. And the source and the drain, they're connected to each other through something called a fin. You can see this fin-like structure, and the gate is deposited on top of the fin-like structure. So because of this, even if the channel length is reduced, because the gate encompasses the channel in all the three sides, it there's more control over there, there's more electrostatic control over there, and that is why FinFET works better. Okay, and we can see the channel length is, we can say it's roughly the distance between the source and the drain. But what about the channel width? Here, the channel width, we define it as the width of the fin. And there are some leakage power analysis. Okay, what are the challenges in FinFET? The challenges in FinFET are much like MOSFETs. The similar challenges, as we know, width of the transistor of the device is half the channel length. If the device scale is down, it is necessary to decrease its channel length, which improves its drive strength of the transistor. However, smaller gate length, transistors have less control over the channel and exponentially higher subthreshold leakage. Okay, what does high subthreshold leakage mean? When the voltage on the gate is less than the threshold, all the current in the transistors must be off. There should be no current. But because the transistors are not ideal, even when the voltage on the gate of the transistor is less than the threshold voltage, there is some current, and this phenomenon is made worse when the channel is very short. So again, that the solution of that is to make the tri-gate FinFET or the quasi-planar FinFET. In this diagram, we can see the first one is a planar FinFET, which is very similar to a MOSFET, and the second one is a tri-gate FinFET, in which the source and the drain are all protruding out and the gate is over the channel. And because of that, like I said, we have higher electrostatic control. 4-bit ALU using FinFET. ALU, or the arithmetic logic unit, performs many functions such as add, addition, subtraction, multiplication, logical functions such as AND, OR, XOR, etc. In this paper, they have they have experimented with some of the functions, adder, subtractor, comparator, and or not an XOR, and they have simulated it, and they have published the results over here. One second. Yes, they have published the results over here, and it works. And this is the leakage power of the ALU circuit. In conclusion, they've said yes, this we can build a FinFET. Sorry, we can build an ALU using the FinFET technique, and the leakage power is found to be 290 nanowatts. Thank you.